For now. All right, thank you. Getting the recording going. Thanks for coming along, everybody. I'm your regular host, Dave Blodgett, chair of the IT&I committee of the Earth Science Information Partners. Stands for Information Technology and Interoperability. We're a co-hosted, co-run group with the U.S. Geological Survey Center for Data or Community for Data Integration. And we run these calls once a month to focus on current topics in IT interoperability. Last year, we had a series that we were calling Rants and Raves that were kind of designed to dig into the highs and lows, goods and bads of IT interoperability. And this year, we're kind of shifting away from that, but keeping a focus on the kind of underlying capacity that we're trying to put in place with new IT arrangements that allow us to do new, exciting, interoperable things. And so kind of thinking about this as the fundamentals of interoperability, if you will, but in the context of new ways of envisioning or new ways of thinking about doing IT interoperability. So with that, this month we have Brian Golden from Voyager Search, who I came across through his involvement in the OGC Disaster Pilot in 2023. A colleague of mine, Rich Frazier at the Federal Geographic Data Committee, has flashed the work that Brian and his team did for the disaster pilot across my screen a few times and said really nice things about it. And I'm excited to hear more, excited to hear what's really behind it, what the capability looks like, because it's doing things with remote sensing and machine learning that I've not seen before, but have kind of always imagined would be pretty useful. So with that, I'll turn it to you, Brian. You can introduce yourself and take us away. Thanks a lot for being with us.
Thank you. Thanks, David. So I'll make a quick introduction and then and also just the way I wanted to handle this portion of the session. So my name is Brian Golden. I'm the founder CEO of Voyager Search. Our focus is on helping people connect to data and essentially help them make better decisions by working with that data and working with information technology, or excuse me, information retrieval capabilities. I think we have an hour, but I have a series of slides that I was going to walk through. This is really focusing on insights that we perform with the Open Geospatial Consortium Disaster Pilot 2023 that David mentioned a little bit ago. And I just want to talk about what we did and also share some of the insights that we have and also touch on a little bit of work going forward from that. There's a new pilot that's just now starting to kick off this year that we're also participating in. So I'll touch on some of that work as well. So if you have any questions, please feel free to interrupt me and I'd be happy to answer anything. And then we'll have plenty of time at the end, I think. So regarding the session, I just wanted to touch on some of the topics I wanted to cover, and then really get down to the meat of it about how we delivered and built and then delivered a solution for this disaster pilot. So the first one I think is really obvious. This basically addressing the challenges of information overload, where sometimes you have so much data, so much information that it can hinder productivity versus helping you with it. And then how do you find the right information at the right time to make good decisions? But the other thing that I think is really important, especially for those of you in the federal government, is it's got to be frustrating, even all the way up to our Congress, when they're providing money, that we spend billions of dollars on data, and we spend large amounts of data or fractions of that on building catalogs with lots of useful information, but it's still really hard to answer basic questions. And often you have to get that data in the hands of an analyst in order to work with the right analysis or integrating a model to find something. So on this topic, I want to talk about how to corral some of that data we want to talk about how to plug in models and how to gain some insights and working with data. That I think is actually a pretty straightforward approach. So our mission in the disaster pilot was really aimed at streamlining first the aspects of connecting to and discovering data with an emphasis on disaster, and that was the focus of the pilot. But also other ways that we can use to not just connect to raw data, but how we can also condition it and enrich it and make it more accessible to plugging in machine learning capabilities or models into the data. And then finally, how can we take that data and after we run models on it, how can we create new observations to gain insights that would help benefit a policymaker or a scientist or some type of some other types of decision maker. So that's really the focus of this. So before I start, I wanted to talk about an example. We were able to work with AmeriGeo, and I'm not sure if you might have seen this or heard about it, but in 2022, they had a really disastrous oil spill, the biggest natural disaster emergency that they had in Peru. And what happened was, I think some volcanic activity happened in Tonga, which created an underwater landslide that sent a wave all the way over to Peru. And during that, when that wave hit, unfortunately, there was an oil company that was doing a fuel transfer operation from a ship to shore or something like that, and they had quite a bit of oil spilt. This became a big emergency that received international attention, and as you can imagine, a lot of people came together to provide information to support this emergency. So we met Miguel, who is a general in the army there, and he also is the director of the Remote Sensing Satellite Institute. So one thing that happened, I thought this was really interesting, is that from the case of maybe getting too much information, where you're really that amount of content can even burden your operations, he put out the need for information, and the community responded. So just starting on the 18th, after he started receiving data, going through here just a short period of time, he started receiving data from a wide variety of sources, a lot of different sensors. But it was almost impossible to digest this information, understand where it's stored, how to access it, like how to interpret it. I mean, they just don't have the capability for that. And as you can imagine, there's a lot of models and machine learning capabilities that could operate on this data, but how do you link those models up with the data? And that's a challenge. So that was one of the things that we focused on in this pilot, is how to make that easier. So in the case of the disaster pilot, if you hadn't heard about it, this is really the background for it. And really the goal was to help improve decision-making and response efforts and by collaborating on workflows between, who are the decision makers and what type of decisions do they need to make, and how do we connect data to help and models to help how to do that. And then how do we shorten readiness, resilience, timeliness of data collection and making the information available to folks. So, so that was the goal. The first thing that we wanted to do was we realized that there's a wide range of disparate data sources that are available from local, state, federal government agencies, and also commercial sources as well. So there's really a lot of disparate content out there. So the first step was to build a registry of content. In doing that, the approach is to really use several different parts of a framework. So the first one is to use existing capabilities to connect to data. So using a series of connectors such as industry standard, even OGC compliant connectors to connect to web services, connect to S3 storage, connect to other catalogs such as Stack and or CSW, an older OGC cataloging capability, or even just connect to FTP servers and wherever that data might be. So having an ability to connect to data is really important, and then iterating over and then reading that data so you get the raw information. The next step that we worked on was to develop pipelines for enriching and conditioning that data. You can imagine when you look at Landsat, or if you look at we'll say Planet, a commercial provider of imagery, obviously the data sets that come out of that tell you about the the scene that was collected, the time it was collected, its geography, maybe the angles that the sensor is pointing, and some basic information, including post-processing information such as cloud cover. But it really doesn't tell you a lot about the sensor itself. I mean, that's implied. But when you're looking at a registry, it helps to add additional information. So we did a lot of work to automatically label and classify and enrich the data to provide a more robust metadata in that process, which we'll talk about a little bit. We also then when it needed to put all that content into a repository, a registry. So we're not copying the data or moving the data. We're essentially you might say a dutiful librarian building a card catalog or a registry of what the content is with pointers to where that data is stored, which I'll show you in a few minutes. And once we have the locations of this content, then we're able to query it and sort it and look for it based on geography and sensor types. And then once we do that, then you could do something simple as just downloading it. But where our goal is to then be able to run processes on that data and do that in an automatic fashion. So that gets to the third or the fourth topic down here is a processing framework that can execute models on data. So you could say, as new content comes in that's within a particular geography, then we want to be able to execute a model on it. And then that model would perform an action, which I'll show you in a few minutes. And then also user interfaces for everything from configuring the system. We had an army of interns that helped us build this, to user interfaces to explore the registry, to even pick data sets that you wanted to execute models on and do that in a way that you don't have to be a programmer, which I'll also demonstrate. And then it doesn't show here, but it also how to expose the whole system through industry standards and so forth. And down on the bottom, I think it's also important is that we're not migrating any data. We're not expecting anyone to change the way they work. There's no way we're going to work with USGS and NASA to talk about the metadata that's exposed for Landsat, or similar. We're not going to talk to Planet about updating their stuff. Like, we just read what's there and then we augment it with additional information. So I like talking about architecture a little bit. So this gives you a hint. So really there's a whole framework, a stack of how to connect to content that we used, and then enrichment pipelines that we can plug in rules to enrich and condition the data. And then we create this collaborative registry of the content. That registry can be used for information retrieval and finding things. It can also be used for data governance to understand chain of custody and fitness of use and zero trust and such. And then whole framework for working with and performing actions on data, to simple downloads, to basic ETL solutions, to running more complex models, and then obviously making that content available. So that's really the framework that we used. Now, getting into some of the meat of this, really this is a user interface that is called HQ. So it's a dashboard. And this little animated GIF walks through from the beginning to say I want to connect to some content, and you can enter in some parameters of the web service or the database connection or the S3 storage or whatnot, where you want to connect to the data, and then configuration properties, including the pipeline for how you want to bring that data in. So we used a nomination process. So we had interns, Rich Fraser, as you mentioned earlier, nominated a lot of content, and we really worked with national data sets to subnational and academic and commercial and other types of content. So we really tried to bring in a lot of data that would be provided from a lot of different places. So we worked with, actually, this is a mistake. It should say we connected to over 190 million data sets during this pilot, with the potential to access billions. It's just a matter of letting the system run longer and configuring it. So we built a registry of about 200 million pieces of content. The next part that we did is this process for enriching. So this is really, quite honestly, with this framework right now, we did what I would consider basic enrichment. So we looked at data and we applied a lexicon that would allow us to label the type of organization it came from. We classified it based on some AmeriGeo standards. And then in order to build a registry that gave you good faceted search and filtering and bring things together. Some of it is low tech, such as normalizing a field such as like date created or date captured. You can imagine that content coming from different sources has a lot of different date fields, and we need to standardize on those. And other processes could be more sophisticated, such as running natural language processing to automatically pull out labels for classification and labeling and tagging and so forth. So the results of this process gave us a more a better profile, verified, transformed, like a better a registry to interact with, which I'll give you a little demonstration of in a second as well. So the results of that content this is a screenshot from some of the content that was displayed in the user interface. So this brought in a lot of satellite imagery, a lot of radar and other types of sensor data. It also brought in other vector data sources and also non-spatial documents that we're also able to geotag. So it really recovered a lot of very different data types. And that was from about over almost 200 million things from lots of different countries, different states and departments and so forth. So it was quite broad, and it was pretty fun to pull that together. You can see some heat mapping and so forth to say distribution of data. Here's some really basic like charting, I guess you could say, to allow you to look at data in a different way. So the next part that we want to do, so now we connected to a wide range of data. We've helped enrich and condition that data to bring it together in a registry that is then searchable and interactable with. The next thing that we wanted to do is basically use a processing framework that could be used for simple data download. It could also be used for running ETL processes on data, but here we want to focus on executing models on data. So the thing here is that I can tell you from our company, we certainly worked with machine learning models. We train models. We use a lot of different open source technology, but the reality is there's a zillion models out there that have been developed by commercial organizations, models that have been created through grant and other programs, or models being built by your colleagues in the government. And so there's a lot of models out there. There's a lot of different ways you can execute those models. Really, our focus is to embrace the fact that there's a lot of models and really know that we're basically connecting the data with the model and then running it and then executing the model and then capturing the results of that model. So our focus was on on the top left is a flexible integration that allows us to really invoke the models running in any environment by either hosting the model on our machines in an AWS environment by creating the necessary software prerequisites that those models would run, or calling a model that was hosted by someone else by just passing them parameters, including the path to the data. So we were able to integrate a wide range of models, and in that case, work with a lot of different like diverse model types, just as we have with data. In doing that, the last couple things I think are really important is that it's not really about, I don't think it's about executing a model and then allowing an analyst to just download the results. One of the things that we've done is we needed to keep track of this model was executed with certain parameters and it executed on this data. So now you know that you have insights, or you might say observations that were gathered from that particular data source. And then keeping track of that through lineage, I think, is also very important. It's important for someone to go back and check the work to make sure that they trust those results. The other thing that we did is we wrote all those results back into the registry as individual records and observations so that they could then become searchable and findable, which is really powerful because that means that, for example, we did some work to detect oil spills around South America. So we were able to bring in the right imagery. We found a model that Esri had built. We used some models from Esri mostly because quite frankly, they're productized and very easy to execute. We installed the framework, and then we could just essentially run any model we wanted without any fuss. So that worked out really well. So we knew data was coming in. We found a model that looked at oil sheen to detect oil spill potential. And then we could set a watch box saying that anytime we found new imagery that had a particular amount of little cloud cover, then we can execute a model. And then that model would then output the results to some polygons that would be written back to the registry that someone could then become alerted to, saying that, hey, there's a new polygon, and that they could look at it. I think that's really important because it allows you to like provide models and output without people having to really understand how those models run. And then they can get the results. Also, if you look at someone that's maybe working in a country around South America, they don't have time to download data. They don't have necessarily have the resources to execute those models, collect the data, execute the models themselves, just to find out maybe nothing happened. You know, they want to automate that process. The last thing I think is important about this lineage is that, you know, when I'm purchasing something for my company, I want to make sure I can validate, like, why did we get that, and why did we buy that, or what was the value of that. When you look at it, if you're buying data, I think it's really important to be able to tie the results of modeling activities back to the data. So you can say that, hey, this one scene of Landsat imagery was used to substantiate and capture this many observations. That was, you know, just that one scene was incredibly useful. So you can start showing, you know, the value of doing that. So I think you can tie the results directly to the source data sets. So for the sake of this pilot, we worked with topics: wildfire, drought, oil spills, and climate. Those were the topics that we were given and we were asked to focus on. And we plugged in various models. As I mentioned, we had a lot of data, and then we basically looked for models that could do certain things. So one of the ones that happened during the pilot was actually the Hawaii or the Maui wildfires that everyone's heard about. So we did some structural damage assessments, which I'll demonstrate. I'll show you in a minute. I already talked about some oil spill detection. So we found a model that did oil spills. We also found some folks in the Department of Energy that were interested in solar panels. You know, there's a lot of money being spent on improving the well-being of various populations. And one of the things we can do is provide electricity, and that is often done through solar panels. So you want to be able to measure the amount of solar panels that are going up in areas for lots of different reasons. But we found a model that detects solar panels. We also found a model that detects wind turbines. And then also some more environmental side of mangrove and tree detection. And we could use that to provide some indicators for ecosystem management. And then obviously things like land classification and fire and stuff, which are pretty classic examples of these types of models. So this series, I have a series of slides, and I can also show a live demonstration of the catalog in a few minutes, or the registry. This is a really quick walkthrough. I tried to make some screenshots that would give you a top-down demonstration of exactly how this works. So this is a fire damage assessment. So it's using Earth observation data, imagery, and also vector data, building footprints, to assess damage. And here's the front page. So this is just a front view of this registry. You can see the URLs, OGC DP23. That's live right now. It's accessible. So this is the front page. The next thing we did is there's a lot of ways you can get building footprints. And we know FEMA has structures now, a structures data set. We wanted to do it the hardest way possible, probably. We took early satellite imagery, and we found a building footprint model that would allow you to detect building footprints. So we wanted to run that model to detect building footprints. And the results of that model, we pulled back into the registry as individual records, or these observations, these objects, and we brought them into the registry. So we were able to select And in this case, we looked at the building footprints that are around the area that had fire damage. And then what we did is we basically have this menu here, this action, and it says, if you can read it, it says add items to a cart. So we have this concept of a shopping cart. I mean, we basically don't want to provide any custom training, so we're trying to use concepts that are very familiar with folks. So you can take data, you can add it to a cart, you can see what's been added to the cart, and then you can pick from a list of models that you might want to run on that data. So it's actually quite simple. So here are these are deep learning, machine learning models, samples only, not for official use. So like this is a pilot, but basically we have a model here for damage assessments. We had a model for mangrove detection, for oil spills, and all the things that I talked about. And we had some other integrating with other models as well. So you can basically pick a model, and now it's up to the model to know the model can operate on certain types of data. So we had to provide some logic for that. Now, once we pick the right model, we can execute the model. It already knew how to access the most recent imagery. And in that case, now we found the results. And as I mentioned earlier, we simply wrote the results back to the registry so that they can be found by other people, and multiple people won't be running the same model to get the same data, ideally. So here's the results of that model. And it shows you damaged buildings. And we use a little chip from the satellite imagery to show you where the buildings were, to provide a little bit of context. So that was taking it from soup to nuts from beginning to end on a little one of the modeling exercises. I only have a few more slides, and then I can show you a couple things in a live demo, and then we can talk. So from a lessons learned perspective, I think probably the most interesting thing is we really need more model metadata. And I would say we need a standard for model metadata, because it's really important to understand what this model is, what it does, what type of data it requires, from what type of sensors, what the parameters are. So you can link data with the models. I mean, it takes a lot of work to track that down and understand it. And this doesn't have to be that it has to run in a particular environment. It's just some basic information about what this model does and how it works and what its requirements are. I think that from a data governance and readiness, fit for use. So it's like, there's a lot of discussion about analysis ready data, fit for use data. I think that comes down to data governance actions to really, how do you build these types of registries and to give people confidence in the data that you're working on. This gets to a lot of initiatives right now on zero trust, as I'm sure you're familiar with, which I think is very, very important. The other element is we've built a registry here of a couple 100 million things. It could easily be 1 billion things, but there's an opportunity for lots of these systems to be deployed and linked together to help broaden building it, lots of engines for broader scalability and linking things together. And a lot of that's done through OGC standards and relationships. As you're probably familiar, policies and legal frameworks for licensing and use of data. I think that's also really important. And then these public-private partnerships. We hear from the states all the time that they need more resources from the federal government. I'm sure the federal government would like to have more, feedback and access to state types of content, local content, and so forth. And then even commercial data. Regarding our work, we have been included in a new pilot through OGC that's a continuation of this. And our work is really going to be in a couple of different areas. The first one is actually just focusing on expanding this registry with more content. And the other thing that we're going to be working on is building even more robust metadata. So we did a lot of, I think I would classify it as basic labeling and classification and some normalizing of content so that things can flow together nicely. But there's a lot of really interesting work to expand on the lexicon, expand on much more robust information about data, the sensors, the data was captured from the sensors and tie all that together so that we can have a more automated way of linking models with data. And we're also working on some areas for automated metadata generation. So using machine learning models to examine data, even getting down into at the record level to understanding the essence of what a data set is. It's like the most basic thing is like taking a data set, reading all the data, uniting together all the geometry, and understanding what the footprint is. Like you could do some basic things that everyone's already doing now. But I think looking at vector data attributes, looking at imagery, looking at different things to help classify, label, and automatically generate metadata for improved SDI is important. And then also obviously scaling system, but then probably one of the more I'm personally very excited about is incorporating blockchain technology to support zero trust and looking at chain of custody so that we can know this data came from this trusted source, and hashing that data, doing some basic stuff to understand its identity. And then if we ever see it again, we can match it up and know where it came from, but also looking at improving the lineage aspects of content that's created as derivative products and showing how that relates back to the source content. Some basic things that are pretty fundamental in blockchain to record that. So that's another area that we're working on, and we'll be doing this this spring and summer. It takes a village, you might say. So we were fortunate to be able to work with a lot of different organizations on the pilot. That was a great experience. I have to give the biggest shout out to the bottom right corner, where we really delivered a framework and tools and ideas. And we were able to work with over 34 GeoPathways interns that were able to really configure, plug content in the system, learn about these models, integrate the models, test them, and really like knocked it out of the park. Quite honestly, I was a little stressed when we started the project. We knew that we're going to have that many interns, and I immediately talked to my team about putting together a framework and using Jira to create tasks and training and like getting people up to speed. And I mean, frankly, by the time we figured out what we were going to do in that fashion, they'd already done tons of work. Like they basically just started poking at the system, playing with it, and ran with it. So there was really, training on the fly, and just we learned a lot from watching them. So it was really, really a great experience. So here's my contact information. I'm sure you'll get that if you haven't already. So that's that. And I do have a couple things I can give you a quick demonstration of with a live system. But before I do that, does anyone have any questions? Can you guys still hear me? I hope so.
We can. I was giving others a chance to pipe up. Feel free to come off mute and post questions if anybody has them. Brian, can you go back to your lessons learned slide? Because I want to do you feel like, I guess, something I wonder if there's some synergies. Do you feel like your model metadata and, well, actually, all the first three bullets, can you talk a little bit about the interplay between those three?
Yeah, I think that, well, we'll start with data. I mean, everyone wants to use the right data for their analysis, and I think, I mean, metadata, I mean, right now where the world's going with machine learning models and LLMs and other types of like that family of technology. I mean, the person that has the best metadata and the best data is the one that's going to have their data used the most. And I just think that it's incredibly important for our community to have really solid metadata about the content that's being shared. And the computer itself is not really going to know. I mean, it's great that there's a scene or something, but we need to be able to, we need to be able to talk more about the sensor and the sensor capability and where it came from in order to have a more automated processes in place to link models with that data. So I think that the idea of more robust metadata is really, really important. I mean, I've been working in the GIS industry for 25, 30 years, well, almost 30 years. And if you talk to me when I was younger, I mean, I didn't care about metadata. I mean, because like, we're just creating data and we're doing cool stuff with it, but you're not filling out those forms. I think that as we're building these systems now, you realize just how important that is. And and um there's possible to, by understanding a lexicon and basic glossaries and how organizations work and who created, what vendor created the data, what program created the data, what sensors are available, what was captured. Like there's a lot of cool stuff you can do without a lot of work, I think. The other thing is, um, that fits into governance. I mean, we work with our customers all the time and they have a requirement to share data, but they need to be able to know what they can and can't share. They need to make sure it's fit for use and fit for that purpose. And that all comes right back to metadata. And it feeds right into zero trust, which is, incredibly important initiatives right now, because I think we all agree on. And then and then the next part is like, I don't even know if there, honestly, I don't know if there's any metadata standards for models themselves. Actually, well, I guess I do, but um, that's an area that I think we need a lot of work. You go to Hugging Face and you can see basic information, but that's how they're providing it. If you look at, even if you go to a vendor, I mentioned Esri, they've got lots of models, but really it's hard to, we had to call their internal development team to figure out what data they use to train that model on. And so because we weren't getting the same results that we thought we should. And so I think documenting that, and I can't even describe. I mean, there's so many grants out there. I know that people are building models all the time, but as far as I know, a lot of them run on their own computers. They're not meant for sharing with other people. And but I think that we need to get those things out in the hands of other people. So I hope that helps.
Yeah, it does. I mean, for a long, long time, I've looked at the landscape of metadata standards and actually seen a need to use that metadata framework to inform the other pieces that we're talking about here. Like you got to know what data is good to use for. You got to know how to actually actionably use it. You got to know it has nothing to do with the data. It's all metadata. Like how does this all fit together? And I think you've laid out. This is the most complete implementation where you have a metadata registry that allows you to connect the dots in this way. And these lessons learned leave clearly there's a lot of work to do, but you've been able to, based on what we have, stitch together something pretty meaningful. That's good. It's great.
Yeah. Well, I mean, first of all, everything I showed used for the most part, our company's technology. But so there's two parts to that. One is like, I mean, we spent years building technology and we've taken Humpty Dumpty apart many times to put it back together, at great cost and effort to improve efficiencies and scalabilities and all that jazz. But when you really come down to it, this is not rocket science. Like we're basically building a robust metadata registry and then being able to search it and find stuff and then linking it up with models and then executing those models, which is really just running them in an environment, and then not just downloading the results, but reincorporating them back into the registry where they can be available for other people. It's I mean, honestly, I think it's actually pretty basic, but being able to do that in a way that's like relatively easy and scalable, it does take a lot of work. But it's not a technology problem.
Yeah. Yeah, no, the metadata is the knowledge system in a lot of ways, and it seems trivial, but it's not easy. So good. Any other questions?
All right. I think
There
that
is a
there's
question at the chat.
in the chat.
I'm sorry, I don't have the chat up.
I have it. If you have not, I'll look at the last one. If you have not done yet, please sign up here. Okay. Please do join the notes. I don't think
Oh yeah, no, there's no.
I don't think there's any I don't see any questions yet.
No, I don't either. Okay.
Oh, here you go.
It was a
Sharif,
direct message. Yeah.
I may have missed some of this at the beginning, and if so, please ignore my question. Will you talk a bit about computational costs, either processing, storage, ingress, et cetera, with the enrichment and conditioning pipelines? What roadblocks do you have or have you run into with sharing from an entity security perspective? So from computational costs, our company did this as an in-kind work with OGC. So we donated software our time, but we were lucky. I felt happy that we were able to work with Esri, who provides some software, and we also worked at AWS. And AWS provided infrastructure, and at some point that did come down to cost. So you're talking about a few $1,000s to run a system like this per month. And so to give you a sense for infrastructure cost, computational cost, what happens is you have we call them agents, but they're the things that actually go out and like read the data, and they're also responsible for executing the pipelines. And then they send back really JSON documents with information and maybe packets of thumbnails and other things to it uses a Solar Lucene database, and that Solar Lucene database is spread out across multiple computers as a cluster. So you're just you need computers for storing the registry, and then you also need computers to run the processing aspects. The computational costs the processes of bringing data are really small, because you're really talking about like really simple steps to enrich and condition the data. I think that when you're running models on the data, then there's two ways you can run a model to gather insights or observations and stuff. One is as the data is coming in and I'll say being indexed, you can run a model then. Or you can just let the data flow into the registry, and then after the fact, then you can search the registry, say, is there new data in this geography of this sensor type with some other conditions? And if so, then I want to run this model on it. And I think that's a better approach, because then that performance you don't have the performance hit of running a more time-intensive model during ingestion. Also, you can run lots of models, after the fact. And then you're also, quite frankly, there's models that we haven't thought about yet that we're going to want to run, and you don't necessarily want to just re-index the data and have it tied to that indexing process. So there's some efficiencies there. And plus, I mean, you don't want to look for change in the whole ocean, right? You really want to tie it to just very specific things that you care about, to help reduce the costs further. I think lastly, you could also say the person that cares about this can take the burden of running those processes in their space, but then contributing the results back to the registry where the rest of the scientific community can use them. So you can share the cost of that, and everyone can benefit from it. The last part of that question, I hope I answered that. You can let me know in a minute. And then the other part was, do we run into roadblocks with sharing from an entity and security perspective? I would say from a technology standpoint, absolutely not. There's no problems. It's just you have to understand what you want to do. So the system has, right now it's set up for anonymous access, but we also have single sign-on. And then from that, you can determine what features the person has access to in the software, but you can also determine what data they can see. So if you had sensitive data, then you have options. You can hide it. So if I had a registry of 1 billion things, then certain people might only see a few 100 million. They would never know that it's there. Or the thing I prefer is, for example, if you don't have a license to access Maxar, Planet, Airbus, whatever vendor's data. There's a lot of providers. You at least want to know the data is there, but then you can request permission, from your purchasing people or from the vendor to get access to it. So, I like the idea of having a registry that shows you everything. And then, but if you don't have access, then you can know to request it versus tasking something to try to collect data or something like that. So, but you can set up security in whatever fashion is like. So, all right. Okay. David, do you want me to? We have, I guess this is time's flying by. Do you want me to bring up just a really quick demonstration?
Yeah, if you've got the super quick, I guess people probably be curious to see. We've got a few minutes left here.
I'll just do one. I'll do I'll do a quick like for example, here's a catalog, an instance of this, some highlighted content or something. We have been working with different types of data. So here's some orthoimagery. See if this thing is. And then this should show you recent imagery that's been what's happening here. As soon as I tell you I do a live demo, what's happening? Oh, there you go. So here's some Landsat content that's been captured. What's today? Oh, today. So here's the daily feed. So so there's there looks like there's some imagery. And then fastest search something. My internet, maybe it's my connection here. But you'll be able to see these pages should load super fast. So you'll be able to see imagery that's coming in, where that is at. So it gives you a sense of what's available. Some of this content from the OGC, from the disaster pilot, these are basically various data sources that were captured. And when you look at some of these things, like here's a storm track that we picked up from whatever thing we indexed. It shows you interesting patterns also. So we see description of content. If we click here, it would open up the map that it's associated to. But we can also see things like, for example, this map uses these different data sources, like world imagery is probably a base map. The storm track and some other hourly historical archive image service or something like that. So if you click on these guys, you can start also looking at relationships across content. So this map service itself has these different layers in it, and then it was used across all these different products. So you can start also finding relationships across content, not just, you can find raw data, you can find these observations, you can also find relationships across how that data was used in other types of information products. And then you have faceted searches and so forth. So, yeah, and then, classified and whatever. So you can really pick and poke at this stuff. The options, people can thumbs up, thumbs down. As you're looking at a particular data set, there's also options. If it looks like I'm logged in here, so you can add tags and labels. You can see relationships across that content, its raw metadata values. You can add things to that cart. You can see what's in the cart. If you were looking for, content in a particular area, maybe if I'm going to look at like, I'll just say water, something really broad. And some of this, you'll see water, and it shows you keywords that match this, but it also shows you a word vector, which is a model for, basically a fancy machine learning based synonym generator to expand the searches out. And then, yeah, if you find a search that you like to save, then you can click save it. You can receive email notifications, other things, or you could say if something happens with this data now, something comes into my view, now I want to run it automatically through a model or do something with it, so you can perform actions. It's kind of like like a Zillow. When you're shopping for houses, you can save those parameters, it'll notify you. I mean, really straightforward things. So yeah, And then I will show you one more thing actually, because I think it's nice, is that there are some dashboard views where you can look at like content based on like I'm not sure what this is, total number of resources index based on state, based on whatever. And so the interns set up various reports to start looking at like what was brought in the system. So this is like a Tableau like a view into data to create dashboards and show you how the system's growing, what you've got. So so that's it.
Cool. So then the faceted search is what you were talking about as the kind of the user experience component of the whole architecture.
Yes.
Okay.
So like here, these are themes that were identified. Building sentiments, fisheries, countries, and so these types of so so this gives you a look into that data. You can imagine the more diverse content you bring in, the more like fields and properties and other things are going to be available to you. There aren't penalties for like how many like terms you have or bins and ways you classify the data. You also, I mean, quite honestly, I'll show something that was a mistake. We had at one point we had folks who were configuring the system and they were putting in like emoji type of characters as the country flags into the description. So, the system used that. So, this is something where you'd have to have some, we need to go back and make sure that it's standardized. So
Make sure we ban emojis.
yes, exactly.
Get out of here. Ay, ay, ay.
I know.
Love it. Love it.
So, but I
So
mean,
then
it's
what is I mean, we've got 5 minutes left here, so you don't have to go into any great detail, but like, what does it look like to add an additional model to your pipeline?
it is here.
Like what's the developer experience?
Let me try to log in here.
I mean, you don't necessarily have to demo it. I'm just kind of curious. Are you able to implement models without a developer committing code to a repository or
Yes. Oh wait, let me do this. Actually, yes, let me do it here. So there's two ways you can do it. I'll talk about the pipeline first. So when you're creating a pipeline, like there's lots of pipelines, like, these were created by folks. And if I look at like here, here's one with just one step, it looks like. So I don't know what this is, but I'm going to edit it. It shows you the process that's running on this pipeline, and it's going to basically like it's going to do something. It's setting a value for a field, so adding a value to a field. But you can add steps, and then when you're adding steps, you have a menu of different things that you want to run on that data to help enrich it and condition it in certain ways. And from doing basic stuff like generating a thumbnail to adding values to spatially like classifying documents based on or things based on geography, doing language translations, all kinds of stuff. And but then you can write new tasks using Java, JavaScript, using Python, and then you can test them, you can add it, and then they show up here where other people can use it. Probably the easiest way is to even write JavaScript in an editor here so that you can manipulate it yourself. And I mean, I used to program, but I don't anymore. But I mean, quite honestly, I impressed my team because I got in there and started doing some things. And I was using ChatGPT and saying I need a JavaScript that did this, and just like I just copy pasted. It was pretty amazing. So you can use this to manipulate the data itself by just working this environment.
So you've got kind of a no code configuration with override code abilities. That's nice. That's really cool.
Yeah, and when it comes to no code, it really is that easy where say I want to connect to a folder or S3 storage and whatnot, and then you basically I'll just go here to folder because I don't have an S3 path, but you can say it's the C drive, and then you next, and you really either I just want to get done, and sometimes that's the best way to go so that you can just see what you've got, or you can go to custom settings and you walk through a wizard of, do I want to like OCR documents, or do I want to like unzip files, like unzip zip archives to see what's in them? Or do you want to create that pipeline or schedule things to run new tasks at regular intervals to like reindex? And I mean, really just walk through this, and then system starts building it, like rolling in data.
Neat.
Yeah.
It's almost like the cloud or something. Beautiful.
Yeah.
All right, well, let's cut it off there. Thank you so much. Give everybody a couple minutes here. This will get recorded up on YouTube. I'll get notes transferred over to the wiki. Next month, ESIP staff is going to be presenting on the new webpage they've put together and the process that they went through to get there. So looking forward to that. It'll be something entirely different. But thank you so much for your time, Brian, and we'll be in touch.
All right. Thanks a lot. Have a great day.
Cool. Thanks a lot, everybody. Bye.
Thank you, everyone.
Thanks.